Hey everyone, welcome back to Engineer Empire. I'm a software engineer turned corporate VP and head of technology. I dive into topics like finance, business, and engineering. If that interests you, please hit like or subscribe. Today I'm reacting to Inside the World's Largest 3D Printed Neighborhood.
This is now the world's largest 3D printed community. Lennar, one of the nation's biggest home builders, partnered with Icon, a 3D printing company, to build the community. 100 homes finished faster than it would have taken to build conventionally.
Wow, 100. That's actually quite a few. This sounds like it's actually more prevalent than I thought it was. I think I've seen a couple of videos of this happening in the news and other things, and it does seem like a really cool idea, but I didn't think we were actually using it for homes outside of like one or two experiments at this point.
This community, on the outskirts of Austin, was a trial run that took roughly 2 years to print.
I see. So this was a trial run, but they specifically did an entire community. They just didn't do like a single home, for instance. That makes sense. But 2 years is quite a bit of time, but for 100 homes, that's actually pretty quick, I think.
But the lessons learned here promise to make the process even faster in the future.
You can't.
Yeah, I've seen a lot of like videos of this, of like it kind of moving the like cement kind of feeder or whatever it's called so that it can kind of build these layers. I've seen a lot of those like short clips about that.
Learn that stuff in a lab. You have to get out here in the field with the weather, with the trades. You have to put it out there for customers.
Labor is lean and the cost of building materials is rising. 3D printing could solve some of that. Critical at a time when housing affordability is about.
This does make sense that it would definitely drastically reduce the amount of labor if you could just basically print a home, because then you'd have the equipment there. You wouldn't have to hire anyone to like kind of build out that initial portion. I am curious how they deal with the foundation. I would assume you'd still have to kind of like dig out a layer for the foundation, though they might still 3D print it, or they might even do that normally, because that seems like a fairly straightforward process, certainly much easier than like building and framing a home in a particular way. I'm also interested in the fact that like actually a lot of American homes are built with wood framing as their primary material, and cement is much more prevalent in other countries, and it seems like something that we should do at a high level. I think for most of what I've interpreted for the reason not to is primarily cost comes up quite a bit, of how abundant wood is and how easy it is to build with it and adjust homes with it, which kind of encourages that type of buying and material in America, especially because our homes are generally bigger than in other countries as well. So if you could reduce costs on material a bit, that actually makes it a bit more affordable. But building something for the long term, I think, is something that makes sense, especially when you're thinking about a home, and especially considering how expensive homes are now, that you would likely want a home that is going to stand the test of time.
About the worst in history, and the nation is short roughly 4 million homes. Holly Feekings and her husband moved in just over a year ago.
Well, my son discovered it first, and he's a techie, and he was enthralled with the actual concept and the energy efficiency.
There's actually just like a cool image right here that I just wanted to pause in on. I haven't seen a home complete like this. I've just seen kind of like the cement pouring, as I previously mentioned. It's interesting that you can actually like see the lines, which makes sense because it drips out and it makes that shape. I had always assumed that like some process or somebody like literally would go back and flatten them later, but I guess it makes sense for the cheapest option. You just leave it as is, and it kind of adds this texture, which I don't know. I'm a little torn. At first glance, it's interesting, but also if it was like this throughout your entire home, I'm not sure if that would get boring or not, but it is very interesting, as it's not a standard aesthetic, even in cement houses in other countries or even in America, if you would go that way, because they would be perfectly flat. And sometimes they even do like drywall and things like that on top of the cement. So it's rarely exposed. It looks like maybe this is just painted cement. I'm not sure why it's kind of this light color, unless they did paint it or they treated the cement in some way for it to be this color. But it's very interesting that they have these lines throughout the home.
Efficiency. And then we realized, it was really a safe home for two old folks. Single level, no stairs.
The homes are high-tech, energy efficient, wind, fire, and mold resistant.
This is significant improvement.
Wind, fire, and mold resistant is actually a really good benefit, especially for certain areas in the country where this is huge problems for them.
In evolving a housing market that has the ability to change over time.
This was an experiment for Lennar, and costs were slightly higher as they worked through the kinks, but Miller says he's all in.
The ability to adapt modern product to what we need for the future in housing, in building a healthier housing market, is amazing.
Wow.
Come on in. Welcome to our home.
Holly Feekings and her husband are retired. They've always lived in traditional homes, but they saw several reasons to try.
It's interesting that the island was also built with that same, you can see it just in the corner on right now, where you can see that kind of curved layered texture that exists, which is interesting because I wouldn't standardly think of that, but it does make sense. If you can use it for it, why wouldn't you?
The 3D printed model.
What's great is there's no studs, so you can hang pictures and everything anywhere you want. You have to use screws to drill through the, concrete type wall, but it's been wonderful.
The homes here start at just under $400,000. That's about
It says $389,490, just in case you can't see all of it.
comparable to other larger homes in the area.
So what do you like, the most about this house?
Oh gosh, really the energy efficiency.
Feeking says her electric bill was just $26 in January.
Whoa, that's so cheap. I don't know if that's just because of the area that they're in on top of this, but I can't imagine. I've never had an electrical bill that was $26, I don't think. Maybe in an apartment, maybe like a decade or more ago, potentially, but I'm not sure. That's so cheap.
Much lower when compared to the average bill for.
Yeah, this makes sense for what I would normally expect, $130 for a home. That sounds more reasonable to me. $26 is so cheap. This is actually such a great proof of concept that they have here for how energy efficient it is.
Conventional homes.
Actually, it does make sense. One, because you could likely already plan for insulation in between all of them. I think you could see that there were some gaps between some of the layers as they were printing them. But two, also normal homes inherently have holes in them, especially like when you're making the wood framing, because it's not a solid material throughout. And so a lot of building homes is you trying to seal up and then you covering those holes that naturally exist in the framing of the home. Whereas this one, theoretically, especially if they did the foundation as well or just up against the foundation, presumably there would be zero gaps because there was cement framed literally everywhere. So you'd probably have to build the gaps in, as opposed to the opposite with framing, where like you build all the gaps with the framing and then you try to cover them up.
You do have to run your air on hot days, of course, but it'll hold its temperature. You don't have to check the thermostat, everything's automatic. And because of the construction, it really helps. It's very peaceful to live here.
And quiet, I imagine? Is it quieter?
Very quiet. We have a major road right out back and we don't hear it.
And that's the concrete.
It's the concrete and the insulated windows.
Icon and Lennar announced their plans to build this community in 2022. Since then, large-scale robots worked without a break, squeezing out homes like toothpaste, ultimately at the rate of one every 2 weeks. CNBC toured this construction site back in 2022.
Now we're on an active print site, so this is home number 6 in the queue. So actually what we do is we take digital, any sort of standard digital software, we import it into our system we call BuildOS, and it prepares it for robotic construction. So it will automatically do the structural reinforcement placing, the electrical outlets, the plumbing outlets, those kind of things. The promise of
Yeah, that's really cool. So this is kind of that gap that I mentioned that you can kind of see from up above because they do like these loops and you can see that they are kind of going over a wall twice, like once, and then there's kind of that hollow center to the wall. So it seems like it's specifically made for spacing for plumbing, electrical, etc. And again, this is where it's interesting because you're being intentional about the space that exists as opposed to the opposite of how we're building them today. It's a very cool idea.
robotic construction is the promise of automation, reducing labor, therefore reducing labor costs. So right now, minimum number of operators.
I'm just going to pause it here because I think in this image you can see the gaps that I'm referencing. So you can kind of see how in some of these wall areas that there's a gap in between them, and you can especially see it towards the middle where there's a gap kind of in all of these walls and like some of these swooshing features that they have here.
Is 3. I think in the next 12 months we'll automate the Magma completely, so we'll be down to about 2. And I think the sort of holy grail is where one person can watch a dozen systems. You need one person to watch a dozen systems.
But as of now, you have 3 people building a house.
Which is not bad.
As printing progressed, Icon learned how to do it faster and with less labor.
The things we had to learn on this project that we had never done before were like all the logistics of working at scale and the operations of fielding. You know, I think at our highest moment, we had like 11 printers out here working. And so figuring out materials delivery, shift changes, all the logistics of getting printers in the field, and then working in concert with the rest of the Lennar trades to lay foundations, print walls, have people come in and finish out the homes.
The partnership is unique because Lennar is such a large legacy builder and Icon is so new and so small.
This is really in its infancy. As you've said before, 3D printing, we don't see a lot of it. Why is a company as large as Lennar getting into this now?
So listen, we're just getting started. This is all about innovation.
How much will you invest in the technology and in Icon?
Well, we continue to invest in a variety of strategies around changing the methods of production, of construction, and we expect to take this all the way through. I mean, this is the first 100 homes, but we expect to be able to bring this to scale, and at scale, we really bring cycle times down, and we also bring costs down.
Completing the community was a learning process for both
Since you can actually see the foundation here, I just wanted to pause again. It does look like they did a conventional foundation here just because, again, it's flattened and it doesn't appear to have this sort of ridge structure from the layers from the printing. So that does make sense. That is probably something that's much more critical. And also they need to make sure it's level and probably is already something that's fairly straightforward because, again, you're mostly just leveling out the cement and it's a lot of pouring and just shifting it around. Whereas it's far less complicated than like doorways, etc. Though you can see like bars and stuff in this image as well. So there must be manual labor that's going in to add some of these things. And I'd assume that there is some type of reinforcement through other areas as well. So like you can see these kind of like 2 pillars, and there must be some type of beam, I'm guessing, maybe even just above those 2 pillars to kind of set up where they're going to add the next piece to. And I would assume the same thing happens for wood over here on the other sides. Maybe these are how they're building like the tops of the windows, is that maybe they're just layering this wood piece to kind of like seal it off and add a top to it. But there must be some other rigid structures that they're adding on because, again, similar to a standard 3D printer, you can't just like print without a support underneath it because it'll just fall down because it's liquid effectively at that point in time before it solidifies. So you need some type of structure for it to build on top of. And if you're going all the way from the ground up, that's doable here from like the foundation, but any structures that have like the doorways or windows, for instance, wouldn't be able to do that without some type of support.
Icon and Lennar.
The biggest disappointment in the project was, the very painful learnings for about the first third of the project, where we were taking twice as long as we knew on paper we should be taking. Our costs were about twice as much as we knew they should be on paper. And so that was a little bit of a kick in the gut at the beginning, but you get out here, you work it out, and then by the end we were like on pace and on target. And so we got there, but it was, you got to get out here and take your punches to learn the lessons.
What they learned here was a lot. They don't need the walls to be quite as thick. That'll save significant time in printing and money for concrete. They'll also move to a more open floor plan, reducing interior walls. Then they found a more efficient way to move their printers from model to model, which will also save time and labor costs.
For an industry that really hasn't changed at all in 200 years, in the last 2 years, we've seen an innovation that actually works.
But there's an important caveat. These homes are in an area that allows for faster building. In cities that have tighter building laws, homes may be more difficult to print. Other companies like Eden Homes, also in Texas, and Mighty Buildings and Emergent 3D in California are working on similar projects, but have yet to scale to this many at once.
Are these homes as profitable for Lennar as your regular homes?
Right now, they're not. They are mildly less profitable, which is fine. That's the innovation cycle. It takes time, it takes scale.
Lennar and Icon are already in the planning stages of their next community, just 7 miles away. It'll have twice as many homes, and they expect to bring them in at a more affordable price point.
Since we finished this community, we've internally had like a whole redesign of our wall system to be even faster, even more affordable, and to even better integrate with the rest of the trades that have to work around what we do.
Ballard said,
Though I'm a little torn on them making the walls thinner, I guess. It makes sense from an affordability standpoint, but it's curious how they didn't necessarily reference why they were shrinking how thick the walls were, except for a cost optimization piece, especially considering some of the pros that individual who's living in the home said is like they like how insulated it is, they like how quiet it is. Presumably the thicker the walls, the more that would be the case. And so they might be losing some of those benefits to some extent if they make the walls thinner, but I guess it depends on how much.
as they're still designing the next community, but the homes will be larger with a more efficient and much less costly wall system. They'll use the same printers, but he's already looking to new technology.
The next generation of printer is a printer designed to be able to print the entire envelope of the home, the foundation, the wall system, up to multi-story wall system, and even roof structures as the designs dictate. And we're very interested in looking with Lennar at these like hurricane-prone areas, wildfire-prone areas, because all of a sudden you have an entirely resilient shell of a building.
I feel safer in this house than
That would be really cool, actually, especially for those areas that are experiencing natural disasters. If you could basically expect at least the structure of your home to stay intact through like a wildfire, for instance, I'm sure that would be way better for individuals who are in those areas than like losing your home and everything in it. At least you could potentially mitigate some of those costs, and maybe some of your items might still be there afterwards, especially depending on how crazy the wildfire is or other natural disasters. So that is a cool idea, that if they could get the entire shell kind of as one piece, including the roof and the foundation, that would be pretty exciting.
any house I've ever lived in, because it's so well built, it's not going to burn down.
If you look at the wind load in hurricane zones, the opportunity to build this home throughout the state of Florida, my home state, is amazing. In California, sadly, whether it's the rebuilding or whether it's just regular production, the opportunity to build using fire-resistant materials is amazing. We're at early stages with this, but as we mature, we think it can be a sizable part of our business.
Thank you for watching. I'll see you around.